Dear students, welcome to s.mathguru classes. Today we start a new topics, linear differential equation of second order. So, linear differential equations of second order, linear differential equations of second order with constant coefficient. How to solve this type of problem? The general form of the linear differential equation of second order is this: d square y dx² plus P dy dx plus Qy equal to R, where P and Q are constants. This P and Q are constants and R is a function of X or constant. If we get this type of equation, then this is second order differential equation with constant coefficient. These are constant, coefficients are constant, and this is called constant coefficient. And method for finding complementary function. How to find complementary function? When you have to find complementary function, right side you consider 0. Right side you consider 0. So let y equal to e to the power c1 e to the power mx be the y equal to c1 e to the power mx be the complementary function, be the complementary function cf, complementary function of this is d square y dx square plus p dy dx plus q y equal to 0. We consider right side is 0. Now if we differentiate this one second time, then we differentiate here dy dx equal to dy dx equal to, we get c1 the dx of e to the power mx, this is c1 m e to the power mx. If we write directly, we get this. Again, if we differentiate this d square y dx square, then c1 m, this is outside, and this is mx, c1 m, this m square e to the power mx. We get this, and putting the values of this, d square y dx square is c1 e to the power this is c1 m square e to the power mx plus p dy dx. dy dx is c1 m e to the power mx plus q y means e to the power c1 e to the power mx, this equal to 0. So from this we get c1 e to the power mx is common, we get m square plus pm plus q, this equal to 0. This cannot be 0. If this is not 0, then this must be 0. This implies we get m square plus pm plus q equal to 0, where c1 e to the power mx not equal to 0. This not equal to 0. So after solving, we get this equation. This is called auxiliary equation. This is called auxiliary. It is called auxiliary equation. This is AE. Auxiliary equation is AE. So auxiliary equation means directly we have to write this d square y dx square, we get m square. This is d dx, we get m, and this is q. This equation is called auxiliary equation. And if we solving this equation, we get different types. This is quadratic equation. in terms of m. This is quadratic equation. If we solving this equation, then it has different roots. If roots are distinct, real and distinct, we get one solution, and if roots are equal, we get another types of solution, and if roots are complex conjugate, we get another types of problem. Now we consider the types. Equation, we have different types of roots. Case 1 we consider if roots are real and different, that means distinct roots. If the roots are real and distinct, if m1 and m2 are the roots, then CF complementary function equal to C1 e to the power m1x plus C2 e to the power m2x. This will be the complementary function if the roots are real and distinct. Now again, if the roots are case 2, if the roots are real and distinct, if the roots are equal, if the roots are equal, then what you get? Suppose the roots are, if the roots are m1 equal to, suppose roots are m1 comma m1, then CF complementary function will be C1 plus C2x e to the power m1x. This will be our complementary function. Now case 3 we get, in case 3, if the roots are complex, then what we get? Suppose the roots are, if the roots are alpha plus minus I beta, if we get roots are complex conjugate, one is alpha plus I beta, another is alpha minus I beta, then CF equal to e to the power alpha plus I beta x C1 plus C2 e to the power alpha minus I beta x. This is C1 e to the power alpha x and e to the power I beta x. C2 e to the power alpha x e to the power minus I beta x. And from these two e to the power alpha x common, we get C1 e to the power I beta x, C2 e to the power minus I beta x. So again we know this formula, e to the power I theta equal to cos theta plus I sin theta. We know this formula, e to the power I theta means cos theta plus I sin theta. So here we get I theta, theta means beta x. So this will be e to the power alpha x, this is C1 cos beta x plus I sin beta x plus C2, this is minus, if it is minus, here also minus, this is cos beta x minus I sin beta x, we get this. So this will be e to the power alpha x same, and this is C1 cos beta x C1I sin beta x, C2 cos beta x minus C2I sin beta x. this is e to the power alpha x. From this and this, c1 plus c2 cos beta x common, and from this and this sin beta x common, c1i minus c2i sin beta x, we get this. So this will be e to the power alpha x, this we consider a cos beta x, and this one we consider b sin beta x. So this is our result. If the roots are alpha plus minus I beta, by the help of alpha, this is real part, we write e to the power alpha x, and I beta x, then we write a cos beta x plus b sin beta x. A means this one and b means this one. This is the complementary function of the given problem. So I repeat, if the roots are distinct, real and distinct, we get this. This is our complementary function. Roots are equal, then we get this is complementary function. Roots are complex conjugate, then we get this is our complementary function. These are the rules. By using this three rule, we solve all the problems. All of these are very easy, very simple. Let us consider one problem. Solve d square y dx square minus 8 dy dx plus 15y equal to 0. Right answer 0 means no problem. We can easily solve this. Now solution, this equation, we know dy means dy dx and d square y means d square y dx square. So this equation can be written as d square y minus 8 dy plus 15y equal to 0. Now this implies d square minus 8d plus 15y, this equal to 0. Now auxiliary equation just replacing this and putting m, 8m plus 15 equal to 0. Auxiliary equation is this one. Now we factorize this. This is m square minus thrice m minus 5m plus 15 equal to 0, and from this m common, m minus 3, 5 common, m minus 3 equal to 0. This is m minus 3, m minus 5 equal to 0. Then from this we get m equal to 3, m equal to 5. Therefore, we get, hence the required solution is, we recall this case 1, if roots are distinct and real, m1 and m2, then complementary function equal to cf equal to c1 e to the power m1x plus c2 e to the power m2x. If roots are unequal, then we write this is our answer. So here also roots are unequal. Therefore, the general required solution is y equal to c1 e to the power thrice x, c2 e to the power 5x, and this is our answer. Very nice solution and very easy also. Now we consider another problem. Solve d square y minus d square y dx square minus 6 dy dx plus 9y equal to 0. Now this equation can be written as, this is d square minus 6d plus 9y equal to 0, where d square means d means d dx and d square means d square dx square, this one. Now we get this, Therefore, auxiliary equation, this is m square minus 6m plus 9 equal to 0. And this will be middle time break. This is 3m minus 3m plus 9 equal to 0. M common, m minus 3, 3 common, m minus 3 equal to 0. M minus 3, m minus 3 equal to 0. So m equal to 3, m equal to 3. Now we know this formula in case 2. In case 2, you know, if the roots are equal, m1, m1, then the solution is, complementary function is c1 plus c2x e to the power m1x. This is our solution, our complementary function. If roots are equal, we get c1 plus c2x e to the power m1x. Here roots are 3, 3. Roots are equal. Therefore, the required solution is y equal to c1 plus c2x e to the power thrice x, and this is our answer. Clear this solution? Just using this m1 means 3, 3. Using this formula, ultimately you get our answer. So dear students, these are very easy, very interesting. This is the starting problem about constant coefficient, second order linear differential equation with constant coefficient. This is the starting. These are the starting problems, and I hope all of these are easy, and you will get interest from this solution, and these are important for exam also. So if you are enjoying with me, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.